Hello friends and welcome to our next class on overview of BW. In today's class, we will learn about types of application, OLAP and OLTP, online analytical processing and online transaction processing. SAP BW enables online analytical processing for the staging of information from large amounts of operative and historical data. OLAP technology permits multi-dimensional analysis according to various business perspectives. At the core of any OLAP system, it is the concept of an OLAP cube, also called as multi-dimensional cube or a hypercube. It consists of a numeric facts called measures which are categorized by dimensions. OLTP, online transaction processing. It refers to a class of systems that facilitate and manage transaction-oriented application, typically any data entry retrieval transaction processing. OLTP has also been used to refer processing in which the system responds immediately to the user's request. The main emphasis for OLTP system is put on very fast query processing, maintaining data integrity in multi-access environment, and an effective measured by number of transactions per second. In OLTP database, there is detailed and current data, and schema used to store transactional database is the entity model. In general, we can say that OLTP provides source data to data warehouse and the OLAP is used to analyze it. So OLTP is referred as operative environment and OLAP is referred as informative environment. And after this, now we'll take a closer look at OLTP and OLAP. The main objective of our OLTP system is to be quick in transaction oriented application and typically for data entry and retrieval transaction processing, whereas the main objective of our OLAP system is to provide detailed analysis of historical data. OLTP is used for DB operations, database operations like insert, update, delete. So it efficiently does data insert, delete and modify. So OLAP, it is used for how quickly it can read data and not how quickly data gets loaded in it. Normalized and denormalized. What basically normalized means is it is the process of reducing the redundant data in the table. Since the purpose of the OLTP system is to store information quickly, if there is a redundant data stored in multiple tables, you have to go and update several tables, so it reduces the efficiency of the system. OLTP system, they are always highly normalized, and when I say normalized means the redundant data or excess data from the table is deleted. Denormalized. Here there is a large volume of data. The main purpose of storing a data in OLAP system is different here, and we want to store the data in such a fashion that I should be reducing the number of tables reads that I'll be doing when I'll read the data. So here redundancy is good as it allows us to read data as fast as possible. Entity relationship model, ER model, and multidimensional model. So entity relationship model, it is one of the type of data model. So it maintains the relationship between the entity and its attribute in different ways. As you can see over here, we have a very large data flow, and though it is efficient but it is very complex, so it is not good for analysis purpose. On the other hand, we have multidimensional model. It is a structured frame where fact table is placed in the middle surrounded by dimension table. So it's only a one way to design a MDM model, no matter what data warehousing tool we use. So the examples of OLTP system are ECC, SAP CRM, SAP SRM, APO, whereas an example of OLAP system is our BW. At last, we'll be comparing the different parameters of OLTP versus OLAP. Source of data. It's an operational data, the data which we get from our day-to-day transactions. So OLTP are original source of data. Example of R3 system, ECC. Consolidation data. OLAP data comes from various OLTP database. Example, BW system. Purpose of data: to control and run fundamental business tasks. NoLab is used for planning, problem solving, and decision support and taking complex decisions. Processing speed is typically very fast. It depends on the amount of data involved. Batch data refreshes and complex queries may take many hours. Query speed can be improved by creating indexes. Database design: it is highly normalized with many tables. In OLAP, typically denormalized with very few tables, as we are using star schema or snowflake schemas. Age of data, it's very current, whereas OLAP, it stores historical data. Frequency of extraction, high, and OLAP, it's low. Database operation, it add, modify, update, delete, and over here it's only reads the data. Level of analysis, it's less. And OLAP, it's very high. The dataset that is taken where it's for nearly 6 to 18 months, whereas in OLAP, it is for 2 to 7 years. And now we come to our data warehousing concept. Any data warehousing to follow these three steps, that is modeling, ETL, and reporting. In modeling, let's take an example. We have a traditional database like Oracle, MS SQL, and other data sources. So data in both of these databases could be in completely different structure and different format. So first thing we'll do in modeling is we will understand the different table that are associated with database, and then we will be converting the traditional database into a multi-dimensional database by creating different structures such as InfoCube, DSOs. Once that is done, we will move on to our next procedure, that is ETL. ETL stands for extraction, transform, and loading. So data from different sources and different databases is extracted. And transformation means, as we know, the data in different database is stored in different format. Let's suppose in Oracle, male and female are stored as M or F, whereas in MySQL, the same thing stored is in 0 and 1. So to come to a common platform, the transformation is required. And when the transformation is done, we'll be loading the data into our info providers, that is InfoCube and DSOs. Once the data is entered into our info providers, we will be creating reports on them. And we know that it's very simple. It gets comparatively simple to look at a graph and to come to a decision rather than looking at a huge number of records and then coming to a decision. So these are the three steps that we follow in data warehousing concepts.
SAP architecture, Tier 3. As we all know, SAP is a three-tier architecture, so it includes the database layer. So it can be of Oracle, HANA, Microsoft database, and an application layer, so as to read and write it to our database. So there is a two-way communication between application layer and database layer. Application layer points to OLTP and OLAP type of application. As we know, BW is one of a type of analytical processing, and ECC, SRM, CRM, etc. are the type of OLTP application. And so to connect application server and database server, we need a client, and so it is called a three-tier architecture. The client, application server, and database server all together is said to be a three-tier architecture. Now there are two primary ways to log in into SAP. Either we can directly log on as an SAP logon or SAP GUI, else we can go through an EP, that is Enterprise Portal. SAP logon is basically used for the hardcore BW consultant who will be working in modeling, extraction, whereas Enterprise Portal, it is used by managers, senior managers, chief information officer, as it is not relevant for a CIO to go and log in into SAP GUI system and look reports. So what they will do is they will go through browser. but internally what it happens is it remotely connects the application server and database server. So basically enterprise portal is used for looking the output of a report or viewing the, or it is also used to view reports by senior managers and CEOs. Steps to log in into SAP system. First, we will double click on our SAP logon pad icon. A window will appear known as SAP logon pad. We will select the server. Let's suppose I'm selecting ECC 6.0. On double clicking it, I will get another window which will ask me about client, user, password and language. User and password is very similar to our email accounts. Languages, since SAP is used by countries which speak different languages, so the data entered into the system is of different language. So depending upon the region, the language is selected. By default, English is selected, and for English, over here the code is written as EN. And now the concept of client. Like as I've told you earlier, SAP is a three-tier architecture. A company has installed a SAP. Now the SAP is installed on a very large hard drive, let's say 20 TB, and our single client takes a space of about 5 TB. So then there is a wastage of rest of the space. And apart from this, the reason we are creating multiple client is that it allows us to work on multiple projects at the same time. So consider a company has got only one project running. So at least it would require a 3 server or a 3 client, that is development, quality and production. So one should keep in mind that neither of these clients or instances, it is also called as instances, are not aware about the existence of each other. So they do not share any kind of information amongst themselves. So by now we know that client is a 3-digit number and it varies companies to companies. 800 is basically used for training purpose. In companies we have clients such as 100, 110, 300. It can be any 3-digit number. Here we will be specifying the client which we want to log in. Let's suppose in a company 100 client is starting for development, and for another project in development we'll be using 110, and for the another one we'll be using 120. Likewise, it has its client starting from 200 for quality. So for quality it will give for a particular project 210, for another project 220. Similarly for the production, the number would be starting from 300. It can be any 3-digit number. So once giving this detail, we can enter into our system. So now, landscape design architecture. As I have told, we have got 3 servers: development, testing or quality server, production server. The reason why these 3 are built is, so development server is used for creating objects as per the client specification. In testing server, the objects that are built in development server, we will be doing different kinds of testing on it. And once the testing is successful, it is then further moved to the production server where it faces the real-time environment. As we know that these servers are not aware of the existence of each other, the only way to move the data from one server to another is the transportation. In the coming lectures, we will know what is transportation and how to do it. So that's all for today's class. Thank you.